Hi guys, let's look at the next question. The next question that we do is question number 10. It says AB is parallel to EF and is parallel to CD if AB is equal to 22.5, which means this is 22.5. EP is equal to 7.5. So this small section here is 7.5. PC is equal to 15. So this part is 15. BC is equal to 27, so this part is 27. We need to calculate EF, which is this. Okay, I notice that this forms a part of triangle ACB, and this is also a part of triangle ECF. So we should try and prove these two triangles similar. I should be able to get EF with that. So let's start. So in triangle ABC and triangle EFC, what do we have? Number one, angle ACB would be equal to angle ECF. This is common angle. So this angle is common, and I will get angle P or angle E here and angle A here as equal because these are corresponding angles. So let's just write that down. Angle CAB would be equal to angle CEF. These are corresponding angles. What this means is these two triangles are similar by AA test. So triangle ABC is similar to triangle EFC by AA test, which means I should be able to get the proportion of their sides. Let's just write that down, which means what I will get is AB upon EF would be equal to AC upon EC, which would be equal to BC upon FC. The reason for this would be CSST. Now AB I have is 22.5, EF not given, AC is not given, EC I know is 22.5. So AC is, let's take this value as X. So this is X plus 22.5. Yes, and EC is 22.5. BC, which is the big line, I don't know. FC, I don't know. Okay, so BC upon FC. But I have two variables here, so I don't think I'm getting my answer yet from here. So I should look at another set of triangles which will help me get something. So the other set of triangles which I should be able to prove similar easily should be this triangle here, these two vertically opposite triangles, this triangle and this triangle. Let's see if this will help me get anything. So in triangle DPC and triangle EPF, let's see what I have. This is number 6 would be angle CPD would be equal to angle EPF. Reason would be vertically opposite angles. And then the next part would be angle C here and angle E here would be equal because these are alternate angles. So angle DCP would be equal to angle P, not P, angle FEP. These are alternate angles. So angle C and angle E are equal, which means triangle PCD is similar to triangle PEF. This is AA test. Let's write the correspondence of the sides or the ratio of them. So PC upon PE would be equal to PD upon PF, which would be equal to CD upon EF. This is CSST. Let's see if I'll get something from here. I should. Now PC is 15, PE is 7.5. So I have a ratio for sure. And then PD not given. PD is not given. And upon PF not given, we don't even need to calculate. CD, which is 27, upon EF, which we need to calculate. So I should be able to get this from these two paths. This is 11 would be, this is 7.5 into 1, this is 7.5 into 2. Therefore, EF is equal to 27 upon 2, which is 13.5 centimeter. So the first part of the question done, EF has been calculated. Next part, we need to calculate the value of AC. Where is AC? So EF is 13.5. I need to calculate X. Right? So now let me put this in equation 5. When I've got the value of EF, that'll leave me with only one variable. Okay, so put EF is equal to 13.5 in point number 5, and what I get is 22.5 upon 13.5 is equal to X plus 22.5 upon 22.5. Let's see if there's anything common. Let's remove the decimal. So if I remove the decimal, this is divisible by 5. 5 into 2, 10. That's 27. And this is 5 into 4, and that's 45. This is 9 into 3, and this is 9 into 5. What I get is 5 into 22.5 is equal to 3x plus 3 into 22.5, that's 66 and 1.5, that's 67.5, which means this is 100, 110, 112.5. 112.5 minus 67.5 will be equal to 3x, which is 32 here and 12 there, that's 44 and 1 more. So 45 is equal to 3x, which means x is equal to 15 centimeter. So this x here is 15 centimeter, which is AE. What do we have to calculate? AC would be equal to 15 plus 7.5 plus 15, which is equal to 37.5 centimeter. Done. I could have also, yeah, then done. That's the question. Thank you so much. Let's look at the next question. The next question that we do is question number question number 12, not 13. Question number 12. So in PQR are midpoints of these respective sides. Prove the triangle PQR and triangle ABC are similar. So since we are talking about midpoints, which means we can clearly apply midpoint theorem that we learned last year, will make our life very easy. So let's just write that. Let AP is equal to BP is equal to X. Right? So this is X and this is X. Number 2, BQ is equal to CQ is equal to Y. This is Y, and then this is Z. Let's write our assumption. And let AR is equal to RC is equal to Z. So what we need to prove is PQR, which is, this is ABC and this is PQR. This is PRQ, this is A, B and C. AB is 2x, this is 2y, this is 2z, this is, we don't know. So let's just see what we can get. So in triangle ABC, number 4, since P and R are midpoints, therefore PR is parallel to BC and PR is equal to half of BC, which is equal to Y. Right? Half of BC is nothing but BQ, which is Y. Done. So this is point number 5. This is using midpoint theorem. Done. Let's look at the next one. Since P and Q are midpoints, therefore PQ is parallel to AC and PQ is equal to half of AC, which means this is equal to Z. Done. Again using midpoint theorem. So I got PR is equal to Y, I got PQ is equal to Z, Let's see what do I get for QR. Since Q and R are midpoints, therefore QR is parallel to AB and QR is equal to half of AB, which is equal to X. This is again using midpoint theorem. So this is point number 9. Now that we've got our basic things clear, let's try and prove them similar using some method. I notice that they are in the right ratio, which means ABC is exactly the double of PQR. Right? So let's try. PR upon BC is equal to Y upon 2Y is equal to 1 upon 2. That's point number 10. They are corresponding sides. Next, PQ upon AC is equal to Z upon 2Z is equal to 1 by 2. Similarly, QR upon AB is equal to X upon 2X is equal to 1 by 2. So from 10, 11 and 12, since PR upon BC is equal to PQ upon AC is equal to QR upon AB. Therefore, by side test, since all sides are in the same ratio, what we have is triangle PQR is in similar to triangle CAB. Yes, PQR is similar to CAB. Yes, PQR is similar to CAB. Perfect. Please note that this question they wanted us to prove it similar to ABC. This question should have read triangle CAB. Perfect. Interesting question. Maybe the first question that we solved in this chapter using SSS method. Good. Let's look at the next question. The next question that we solve is question number 13. It says in the following figure, AD and CE are medians, which means BD is equal to CD and CE is a median, which means BE is equal to AC. So let's just write that down. BD and BC are equal. Number 1, BD is equal to CD. Number 2, BE is equal to AE. Since AD and CE are medians. Next, DF is parallel to CE. DF is parallel to CE. We need to prove EF and FB are equal. I remember having done a similar question or exactly the same question in class 9th using congruency. This time and midpoint theorem also. I won't use midpoint theorem here. Let's see if we can try and use something else, which is in this case we'll use basic proportionality theorem because that's what we've done it new in this year. So let's look at this triangle BEC in which FB is parallel to the base EC. So in triangle BEC, number 3, since FD is parallel to EC, therefore using basic proportionality theorem, what I get is BF upon, I have very less space. Let me write it on the next line. Very less space here. So number 4, BF upon FE would be equal to BD upon CD. But since BD and CD are equal, this is equal to 1. Since BD is equal to CD from 1. Okay. Therefore, what I get is BF is equal to FE since they are equal. This is my first part of the question done. BF is equal to FE done. Let's look at the second part. The second part says I need to prove AG is to GD is equal to 2 times 1. Okay, so let's look at this. AG, which is, where is G? Why I haven't marked G? Oh, so this point is G, which I haven't marked in the diagram. This point is G. AG is to GD is 2 is to 1. Let's see if I can get something. But before that, let's see if I can get a ratio of AE and EF and BF. Which would mean AE is equal to BE, which means this will be equal to BF plus F. BF plus FE. Therefore, AB would be equal to 2 times FE. Why 2 times FE? AB is equal to BE. What have I written? Oops, completely wrong. Let's just rewrite this. Why is AB equal to BE? AB is equal to BE plus AE. Correct? Yes, that's fine. And AE is equal to BE. That's also fine. BE is equal to BF plus FE, which means AE is equal to 2 times FE, since BF is equal to FE. Maybe I did that wrong. This is AE. So AE is 2 times FE. AE is 2 times FE. Perfect. Let's look at basic proportionality theorem. Now in this triangle AFB, where EG is parallel to the base FD. In triangle AFB, since EG is parallel to FD, using basic proportionality theorem, what I get is AE upon FE would be equal to AG upon GD. Now AE is equal to 2 times FE and FE is obviously FE. This is AG upon GD. FE and FE gets cancelled. So this is 2 upon 1 is equal to AG upon GD, which means AG is to GD. Since they want the answer in the ratio form, we will have to write it in the ratio form. That's what they wanted us to do. That finishes this question for us. But before I finish this video, let's look at your homework questions. Homework question for you would be question number 11. Yeah, that's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye-bye.